Good morning, dear students. Today I am going to discuss the operation of megger. Okay, the megger is used to measure insulation resistance. Okay, so this is used for what? Measure the insulation resistance. Nothing but measurement of resistance. So for measurement of resistance, we use this megger. Okay, let us see the operation of this megger. Okay, so here you have a generator. Okay, for this generator there will be a handle here. Okay, so here permanent magnets will be there. So because of these magnets, what will happen? Flux will be produced. So whenever we rotate this handle, what will happen? So this flux will get cut by this armature and EMF will be induced. Okay, next come to this side. Here D and G. So between this D and G, unknown resistance will be connected. Okay, whatever the resistance we need to measure, that will be connected between what? D and G. And see here, in between this, there is an arrangement and there is a pointer and there is a scale here which is having what? Infinitive here and which is having 0 here, and between there are numbers. This is a scale. And see this circuit, whenever the EMF is generated here, it will flow like this here. So there are mainly two paths for the flow of the current here. So one is what? This one, see here. So A, V2, V, and B, F, C, and again negative. So in this way the current will flow. This is the one path. And the another path which we have here is what? So the current will flow from here plus, again it will come to this A and it will come to this D and it will flow to this unknown resistance and it will come to E. Again from here it will go like this from E. After E it will come here and it will flow through this current coil. This is called as a current coil. So it will go like this from E, it will go to this current coil, again it will return, again it will come to F, and again it will come to C, and it will come to negative, and it will complete its path. So that means here there are two paths for the flow of current. Okay, now let us suppose that here I am not connecting any resistance here between this D and G. That means it is open. It is open means what? Here it is open means what? The resistance is not connected means what? The resistance is infinitive. Okay, the resistance is infinitive. Now this pointer should show what? This infinity value. So how it shows? Let us see here. Now let us take this case 1. So in this case 1 I am not connecting any resistance. I am opening this one. So now I will rotate this handle. What will happen? So the current starts flowing from here. Okay, so it will come here. Why? Because this is open, right? So current will come here. It will come to V2 and it will come to this V. Again it will come to this B and F and C. Like this the current, the path will be what? Completed. Okay, so this coil is called as voltage coil and this coil is called as current coil. So now whenever the resistance is not connected here, what will happen? So the current will flow through this path A, V2, V, B, F, C, and it will complete. So here only one current is flowing through the voltage coil and no current is flowing in this current coil. Okay, so therefore what will happen? So here the only one flux will be produced here in voltage coil. There is no flux produced in this current coil. So therefore here torque will not be produced. In order the torque is produced, here two fluxes are necessary. Since only one current is flowing through this voltage coil, here no flux will be produced and no torque will be produced. Only one flux will be produced and torque will not be produced. So since torque is not produced, the pointer will be there on the infinitive point only. So that means what? When I do not connect any resistance here, the torque will not produced and the pointer shows infinitive. That means what? Here the resistance is what? Infinitive. That means no resistance is connected. So this is the case 1. Now let us take second case. In this case I will connect here some resistance. Okay, so now I will connect here some resistance. Now see here, now let us see the scenario. So now the current will start flowing like this. Okay, so now current will come to this V2 and it will flow through this voltage coil and it will come to BFC and it will come to negative. And another current will also flow. From here the current will divided actually. One current will flow through here like this and another current will come to this D and it will flow through this unknown resistance, okay, which will connect here. It will come to E. After this E it will come to this current coil. It will go upside like this and it will flow in this way and it will come to F and it will come to C. Like this it will come to negative. So now here current is flowing in two paths. One is through this voltage coil, okay, and another one is what? Through this unknown resistance and through this current coil and again through the negative. That means here current is flowing in two paths. One is through voltage coil, another one is through what, this current coil. So therefore what will happen here, two fluxes will be produced. So interaction of these two fluxes will produce what, a torque. So because of this torque, what will happen, the pointer starts rotating and the pointer will indicate some value here. So that value will be proportional to what, the resistance which we have connected here. Okay, so this is the second case. And in third case, let us short these 2 points. That means I have connected here what, a resistance. I have not connected here. Short circuit means what, here short circuit, we will connect a short circuit. Okay, so now let us see what will be the scenario. So now if I connect a short circuit here, what does it mean? It means zero resistance. Right, short circuit means what, zero resistance. Now see here, let us take the third situation. So in this we will take what, a short circuit here. Now let us see here. So this is what, short circuit means what, zero resistance. Now the pointer should indicate what, 0. Now let us see how it shows the 0. Now let us see. Okay, now let us rotate this handle once again. So now EMF will be generated, the current starts flowing like this. Okay, at this point the current will come. Okay, and after this what will happen, here the current will start flowing through this path. Again it will go through this current coil, and again through this path, again the current will through this voltage coil. Again it will come to this BFC. That means here also the current is flowing through what, through the current coil, and here also the current is flowing through the voltage coil. So here also what will happen, the torque will be produced. Here two fluxes will be produced, and here also torque will be produced. So because of this, here what will happen, a maximum torque will be produced and the pointer will deflect and it will show what, the 0 position. Okay, so here maximum torque will be produced and the pointer will indicate what, the 0 position. So this means what, here the resistance which we have connected is what, indicated by what, 0. That means 0 resistance. That means what, the short circuit. So short circuit is nothing but 0 resistance. Okay, so therefore here 3 situations we can explain, what, 3 situations. Okay, first case is what, in first case the resistance, okay, open circuited. Okay, we do not connect any resistance here. So in that situation, so what will happen, so current will flow only through this voltage coil and here torque will not be produced and the pointer will indicate infinitive. That means here resistance connected is what, infinity resistance. That is nothing but what, open circuited. In second case, here we will connect some resistance. So because of this, what will happen, current will start flowing through this voltage coil and also current will flow through this known resistance and it will flow through this current coil. So therefore here some torque will be produced. So because of this, the pointer will indicate some value. So that value will be nothing but what, it is the value of the known resistance. Next, third case. In third case, what we will do, we will connect here a short circuit. So short circuit is nothing but what, 0 resistance. Now what will happen, again we will rotate the handle, again current starts flowing like this. Again the current will flow through this short circuit and it will flow through this current coil and it will through this FC. And again another current will flow through the same voltage coil and it will flow through this what, voltage coil and through this BFC. That means here also 2 fluxes will be produced because of what, one voltage coil, another flux is because of current coil. So therefore here also a torque produced, but here maximum torque will be produced. Why? Because we have connected here what, a short circuit, no resistance. So because of this maximum torque, the pointer will indicate what, 0. So 0 resistance. 0 resistance is nothing but what, short circuit. So this is the working of megger. So this here you can see, this is the notes which I have written, so such that you can understand clearly. So this is first page of my notes and this is the second page of the notes. You can take screenshot also and it will be useful for you in your examination. Okay, so thank you for listening. Bye everyone.